This piece took a lot of planning and research. My goal was to recreate the visuals of kinetic typography with the mechanics of automata toys. I refined my concept through a series of sketches, charting the path of each mechanism throughout its cycle, and making sure that no component interfered with another. When I couldn't visualize the structure, I built a mock-up to understand how it would function in the final piece. These led me to my final design. When the crank is turned, rotational motion is introduced into the system. Every action in the machine stems from this power source. The two input gears set the tempo for the motion, and they also change the direction. These gears have a 1:3 ratio. The right gear is exactly 3 times larger than the left. This means it takes 3 full turns of the crank to equal 1 rotation after the gears. Without this system, the text movement would be too quick to read when turning the crank at a comfortable pace. Inside are 2 pinwheel gears. Their ratio is 1:1, meaning they're the same size. This means they turn at the same rate as the center shaft and stay in perfect sync with the rest of the movement. The use of pins instead of traditional gear teeth makes it easy for them to turn corners. This changes the direction of our rotational motion and delivers power to the cam at the back gear. Cams transform rotational motion into up and down motion. Any distortion from a circular shape creates a vertical event in the cam's cycle. This one gradually lifts up the word because until it abruptly snaps back down. This type is called a snail cam because they traditionally resemble a snail shell. It's a simple example, but they can get a lot more complex. In fact, cams were used to store data on some of the first computers. Continuing along the main shaft on the other side is a device called the Geneva drive. Invented in the 1600s in Geneva, Switzerland for clockworks, it divides the continuous rotation into steps. Each revolution of the lower wheel rotates the upper cross 90 degrees and locks it into place until the next rotation. Once I had planned out these mechanics and the dimensions for each part, I drew a master plan in Illustrator to transfer my cut lines to wood. With the pattern over a 1/4-inch sheet of plywood, I carefully trimmed out each component. The lettering was applied by transferring a laserjet print with acetone. Lastly, I assembled it with washers and glue.